Hello. So in this small video, we are going to be running one of the small demos from the lecture of today, and that's going to be for pre-processing images via a method which is called Differences of Gaussians. A difference of Gaussian is basically a method that we use to enhance objects of a particular size against, all the background, more or less in a uniform way. You will see as an example right now. I do not have a lot of time to cover the theory. That's not the purpose of the video. So I'm just gonna direct you to the information that is in the PDF so that you can find in the links for the material of the course. And you will see that if you go into the definition of difference of Gaussians, you will see that this is sort of equivalent to doing a bandpass filtering in the Fourier space. So it's partially powerful for sort of spot detection because round small objects of a particular size will be enhanced and all other objects will be decreased. And the size that we will enhance will depend on the parameters that we use for the differences of Gaussians. Okay, so how does it work from a practical point of view? That we're going to take is that we're going to take a raw image. That raw image we're going to blur it first via a Gaussian blur of sigma 1, and we're going to subtract a copy of the raw data blurred now by a different sigma, by a sigma 2. And the relationship between the sigmas is this one. Your sigma 2 must be 1.4 times bigger than your sigma 1. All right. So let's have a look at how this will work. And what I'm going to use right now is on the EMBL plugin samples. There is a nice data set to exemplify this procedure, which is the EBI one. Okay. So we're going to open up that image. It's going to take a few seconds because we're going to download it from the website. And here we see it. And if I play this data, you will see that this is a nice example because we have a lot of objects. They are not exactly round, but they're roundish, and they're all more or less of the same size. And they are moving against different levels of background, right? And if we want to track those objects, that will be slightly challenging. So what we would prefer to do is try to maximize the difference between the object and the background, right? We want to enhance those spots. Now, how we're going to do that is by using the DoG concept. So the first thing I'm going to do is I'm going to take my raw data, I'm going to duplicate the data, and I'm going to call this G1 for Gaussian 1, and I make sure to duplicate the full stack. So right now I'm going to run this for a full movie. Okay. Now, once I duplicate, this is just a copy. I have to apply my Gaussian blur. And then you select the 2D version of it. So you have process, filter, Gaussian blur. You run that one. And in this case, just to make it simple for the mathematics, we're going to put a sigma of 1. If I click the preview, you see that that sigma 1 kind of nicely matches the size of my object. If I were to use a too large sigma, I completely lose my objects. If I use an intermediate sigma, you see I still lose them. So a sigma of 1 is a nice match for this particular movie. And we say, okay. It's going to ask me, do you want to apply it for all the images? I say yes. And now I have my Gaussian with sigma 1 blurred image. Then I go to my raw data. I have to duplicate it again. So it's easy to show you. I'm going to go for a Gaussian 2. G2 stands for Gaussian of sigma of the next sigma, and then we're going to duplicate the whole thing. All right. Now in this case, we're going to again apply the Gaussian blur, the 2D version of it. But now we're going to, instead of using a value of 2, we're actually going to do 1.1 times multiplied by 1, right? So it's basically going to be 414, right? And we're going to say, okay, we apply to all of them. All right, so now we have G2, which is more blurred than G1. And now we're going to do the difference between them. And for that, we're going to use the image calculator. So that can be found in process image calculator. Now we're going to take my G1 and I'm going to subtract my G2. Here, as you will see, the idea is that G1 has spots that has been enhanced and G2 has something that looks more like background, right? So then we are going to create a new window, and important in this case, we're going to click on 32-bit float results because we might have negative values, right? After the Gaussian processing. Yeah, sorry, after the subtraction of these two images. So we're going to click OK. We say that yes, we want to process all images, and now we get this resulting movie. Now, at first glance, maybe it doesn't look so interesting for you or so exciting, but if you do image adjust brightness and contrast, and we kind of move away from the background, you will see that all the objects that remain are basically my spots of interest. And if I play this movie, you will see how nicely they have been enhanced against the background that we had. This is the original movie, all right? And now the interesting thing in here is you will see is that this filtering is very powerful against various levels of background. So we cannot see the cell anymore. And even spots that were outside of the main body of this cell are still enhanced to a level which is actually similar to the ones that were in a higher background, right? Also in the nucleus, you can see nice enhanced spots.